don't really write a lot of C code, but I read it all the time and I need to understand it all the time. And extensive macro slop was my greatest enemy in this process. So here we are looking at Linux kernel source code. And in one of the recent versions from about like a year and a half ago, maybe a couple years ago, there was this beautiful piece of code which was a part of implementation of min and max macro that upon expansion produced 47 megabytes. Just think about it, 47 megabytes of preprocessor output, slowing down compilation significantly. And how do you even debug this? How do you even figure out what's going on? And this is actually very hard. If you search online, oh, how do I debug C macros? And like threads on Reddit such as this one, is there a painless way to debug code that makes heavy use of macros? And it's like, no, macros are terrible to debug. It's like, no, macros are lost cause in C. And there are some like decent advices, and maybe let's look into some of these. My interest in this is not purely theoretical. I'm actually creating a program that emulates keyboard input. And in order to do this, you need quite a low-level access to some of Linux features. One of these is uinput. Where is it? There you go. Which lets you create virtual keyboards, virtual mice, and other devices. And in order to do this, you use a lot of ioctl calls. So for example, let's look at this code. And the way it works is it opens uinput file descriptor, and then it specifies which keys you want to register on a newly created virtual keyboard. So my virtual keyboard will be able to press Shift, left shift to be precise, H, E, L, and O. And then what you need to do, you need to call first ioctl that tells you that my virtual device will be able to press keys. Then my virtual device will be able to send synchronization events. And then you loop over the keys that you want to set, and you set them with UI set key bit. And after that, you can assign some metadata to your device, like name it, for example, set vendor product version, after which you call final setup ioctl, after which you create it, and you can finally use the program. So let's compile it. gcc main.c, and if I run a.out, it should register the keyboard, sleep for a little bit, and then insert keys. So I have a helper function send keys. You can specify if you want to use shift, which key code to send, and the delay after you send it. Yes, so a bunch of error handling, but TLDR is that it just creates an input event struct, it fills it with required data, and after that it straight up writes it into the file descriptor. Linux API is actually very simple here. Yes, so blah, 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 and after that it sleeps, right? So if I press and hands off, you see it typed hello with like capital and lowercase letters, and there they are buffered in my terminal. So, and yeah, it's, as you can see in the code, it's not just printing them into a console with printf or anything. It literally like inserts it in a keyboard stream as if, I did myself. As a matter of fact, just to prove it, let's open another terminal. Let's run the program here. I'm switching the focus, and you can see, yeah, here it is typed. The program itself is not very important. I just wanted to show what we are looking here at. And by the way, if you're interested in this kind of things, in input handling on Linux and on Windows, this is kind of my passion territory, my level of expertise. So feel free to leave a comment. I can talk about it a lot, like in depth, so I can create a video about it if you want. But the point being is that these ioctl, so ioctl, yeah, every time you need to use them, you need to pass them some kind of a code. So the way ioctl works, let me look at the manual, yeah. So you provide a file descriptor of ioctl, and then you provide op. And so op is like, it's a macros, yeah. And macros, the manual page kind of points you at which header to look, and which macros are kind of pay attention to. And so the reason why I need to understand these macros is because my program is actually written in Jai programming language. And in Jai, you have built-in bindings generator. So actually, let me show you. So here I have uinput.jai. This is bindings for Linux uinput system, but for Jai that I created and maintain. The issue is that this built-in bindings generator for Jai, it doesn't convert C macros unless they are, a simple defines. And if we go here in the header, so where is, uinput.h, so here. And here are ioctls that we have. So UI-def create and UI-def destroy. And there was another one, UI-def setup. That's kind of more important one. You can see that it is a function, kind of function-like macro. And Jai bindings generator just straight up ignores this. So you must manually, port them. Yeah. And this is what I actually had to do. So this is a Jai code. And so create, destroy, and setup. Yeah, so there's some metaprogramming magic that I had to kind of manually write. In order to do this, I needed to understand how these macros work, how are they implemented, so I don't screw it up and get into some weird bugs. First of all, you can see that there is like underscore IOV that's called with some base, some number, and a struct. And then if you want to go deeper, you need to know what the hell is IOW. And IOW is defined in ioctl somewhere, and you need to go into input.h, and input.h includes ioctl. You go there, and then ioctls, it has like, I think it's in bits, and then asm ioctls. If you remember, a manual page pointed at this header as well, and then you open that, there's like another more generic header, and there you go, a bunch of ioctls, and it also mentions, so I guess we go, wait, is it? There you go, yeah, finally. So yeah, and it defines IOW that also accepts something, and it in turn calls some IOC, which calls IO write, and it has a bunch of like parentheses, macros, and it is a macro that's nested within a macro, that's nested within a macro. At some point it gets here, which is actually kind of understandable, just a bunch of bit shifts, right? And it just calls some like more of a constant macros that Jai bindings generator has no issue with. So I'm not that particularly worried about those. But as you can see, there is quite a bit of complexity here, and it's kind of finicky to port it, so you need to understand what's going on. One way to do this is run a special GCC flag, so -e, and main.c, and you can preprocessed.c. So -e flag of GCC doesn't run the compiler, it stops after preprocessing. And then if you open main.c, not main.c, let's open preprocessed.c, and you can see that it inserted a bunch of stuff here, a bunch of type defs. And so yeah, it expanded all the macros that are used in main. But somewhere down below, you can see that upon calling ioctl and fd, it actually has this. So let me open Emacs to full screen. So this is what it did. It expanded all of these macros from top to bottom and inserted them here verbatim. It also inserted a bunch of like crap, so hashbang, line. This is something that's called a line marker in GCC, and actually you can still compile it, so preprocessed.c, so you can still compile it. These line markers are actually, they are used by the compiler, I think, to insert debug info like correctly. Don't quote me on that. I actually didn't look this up before making this video. Maybe I should have. But yeah, the point being is that you can still call compiled program and it's still gonna work. Yes, so this will work. And if you have some simple macros, maybe just a couple levels deep, you can just use -e. You'll see it unwrapped, and maybe it will help you understand. Another flag that you can pass is, I think it's -p, right? And if you do that, you can see that GCC will strip all of the line markers, making code much, much, much cleaner. And yeah, now here you can see just the code with unwrapped macros. And if your macro consists of multiple lines, you can maybe create some minimal repro, put breakpoints, step into, and yeah, figure out how it works. But it's not always possible, especially here when it's like a bunch of math and break it down line by line, you kind of risk destroying it. I very rarely do this because also you need to kind of isolate the macro, create like a repro, because in your real code there's usually a bunch of macros, all of them getting expanded, and GCC doesn't really have a flag to expand only just one macro, unfortunately. But oh, actually, before we do that, if you read online, people will like, oh yeah, I'm using Visual Studio and I hover on top of the macro, and you know, sometimes it expands and I can like select it and copy, or you can use like CLI and rely on ClangD, being smart about it. And it's not always working. Sometimes it doesn't show you what you want. And people are like, they're really trying to find a solution, but it's all workarounds. And what I'm gonna show you is just another workaround, but it's the one that I kind of like the most when I explore C macros. The thing I'm talking about is called cdecl, and it actually has very long history. It's a very old project. If you read about it, cdecl is a program primarily for composing and deciphering C or C++ declarations or casts, aka gibberish, aka C++ and C slop. But this particular version is also enhanced to explain and expand macros. And it does it in a very, very beautiful way. It's maintained by this beautiful person whose name is Paul J. Lucas, and it only has 114 stars on GitHub, which is embarrassing considering that it's very actively maintained, so please go leave it a star. But yeah, I'm just gonna kind of show you the process of how to explain these ioctls macros with this program. And before I do, it supports a lot of stuff. The only, I guess, issue with this is if you are on Windows, you probably need MinGW to compile it. I think because it depends on like GNU build stack. Maybe there's a Windows build that somebody maintains. I haven't checked. Yeah, so let's go back to the code. And I actually have it installed. And yeah, I'm using Arch, by the way. And so if you use Arch to install it, it has multiple versions of it on AUR. Make sure to install this one, cdecl PGL. It stands for Paul J. Lucas. Yeah, because there is another version without his improvements and it doesn't actually parse macros. So yeah, be careful to install the right version. Yeah, otherwise you can compile it yourself and it's actually pretty easy. Yeah, so it's actually a very simple command line program that drops you into a REPL and you can type, not exclamation mark, sorry, what is it called in English? Question mark, yes, sorry. Yeah, and it kind of explains you what it can do. It has a nice syntax highlighting and stuff. And this is the one we're looking for. And here's the process. So you go kind of from top to bottom. So let me do the setup process. So what I do usually is copy the uinput ioctl base because it's, you know, you just press enter. And then let me clear the prompt. After that, you go and yeah, the setup, this is the one that we needed. Just copy that. So then we copy this one, paste, and after that it depends on IOC, which is bit shifts. I'm actually not gonna copy this one because this is actually a very straightforward, just bit shifts right by size. I'm gonna copy IO right though, so I'm gonna copy this, and that's probably it. Oh, and I guess you can do type check. Yeah. Type check is just kind of size off. So this is, I guess, a way for this macro to do polymorphism, right? So let me copy that, let me paste it, press enter. So yeah, after I pasted however many levels of deep I want, what I do is I press expand, I type expand, and UI dev setup, right? UI dev setup, press enter, and this is what it gives me. Yeah, so let me expand the terminal. Look at how it does it. So it says that UI dev setup, colon underscore IOW with these things, right? And it says that, okay, 3, right? So yeah, just like this. Then what it does, so this IOW, sorry, calls this, and then it starts explaining you the argument. So type is you input ioctl base, right? So there. So IOW type and R archetype. So type is this, and then this base is capital U. So type is U. Next, an R, which is number, I guess. It's 3. Archetype is struct you input setup. And so total, we go back one level so you can see it kind of like shows you in vertical levels. So you go back and now you have underscore IOW that gets called with U, 3 and this struct. And then it calls write and it shows you where exactly you see it, like where it kind of inserts this U, where it inserts the 3. And here's the type check called with this particular struct, and then you can see how write expands, and then you can see how type check expands. So T is the struct, and at the end type checked is just size of the struct, and here you get the full kind of expanded version. So at the end you have IOC of 1U, of U, of 3, of size of this struct. So you see you can kind of go all the way down and see how each individual parameter unwraps, and then it composes it back together. And at the end, you see how this entire thing expands. And if I were to copy IOC, which is bit shifts, it would have done that as well. Actually, there was one quirk with an old version. So just to showcase, if you copy it and paste it, oh no, it actually works. So older versions, they would complain about backslashes and say syntax error. And so you would have to, you know, just like, oh yeah, this buffer is read only. So you would have to just inline this macro and paste it like that. But I guess it works in this version, so yeah. So I use this thing all the time. I really like it to expand macros and slowly understand them. It really helps me. So I just wanted to showcase this tool because, as I said, at least on GitHub, it is criminally underrated. So I want more people to know about it, more people to appreciate the hard work that maintainers do. Yeah. And going back to my Jai version, just to show how I did it, again, so here's my version of IOV, and it passes a struct, and run just runs Jai code at compile time. So this becomes a constant, just like defined in the C code, right? And then I go to ioctl, yeah, here. IOW is another macro, so expand is macro in Jai. And in Jai is actually much easier. You can literally just set a breakpoint and drop down into macro code as if it were a normal code. So this is just one of issues with C macros that Jai very nicely solves. And I don't need to pass any kind of verbatim struct here. I just mark the type as a constant, and it gets polymorphized because in Jai types are first-class citizens. You can pass type as an argument to a function, right? And I can call size of on type. And at the end, I just call this IOC, which are the same kind of bit shifts. So yeah, that thing really helped me to transform these macros in their Jai versions. And now my program in Jai is able to use them. And I am very happy about it. Thank you very much for watching. If you are still here, please subscribe, like all this YouTube stuff. Apparently, if you ask for subscriptions, people subscribe. So yeah, here we are. And I am gonna try to make more videos about low-level programming in the future. So yeah, bye, have a nice day.